let's talk about the alternating series error bound. And this is going to take us a couple minutes to really unpack this idea, but here goes. We're going to have a few variables, and the first one's going to be S, which is the infinite sum of an alternating series. And again, an alternating series is when your signs switch back and forth, like positive, negative, or starting with a negative. S sub n would be the sum of the first n terms, and then R sub n is the sum of the remaining terms. It's like the remainder, and that n is actually, it's going to start after that. So for example, if I wanted to go ahead and start the example down here, which I think we can go ahead and start to do just as an example, we're going to plug in a 1 for n. When we plug in a 1 for n, well, we have a 1 squared in the denominator. I'm going to write way too much here, but let's do it. 1 goes here, 1 plus 1, of course, is 2. Negative 1 squared is positive 1. So that's my first term. And then it's blurry. Oh, there we go. Back in focus. Let's plug in a 2, and that gives me a 4. So 2 squared. There we go. And I don't know why I'm writing all that. I could have just written a 4, but we'll do it. So plug in a 2 gives me a 3. Negative to an odd power is going to give me a negative. And then I'm going to actually write the first 5 or 6 terms. And then 3 squared, and then 4 squared, and then 5 squared, and then we'll just keep going from there. Let's go ahead and put 1 here, and then negative 1 here, and then positive 1 here. So that's what I have. So we're really going to have 1 minus 1/4 plus 1/9. I said I was going to write way too much. Whoops. And I am writing way too much. But I think you're going to get the point of it when I write all of this down. Okay, so minus 1 over 36 plus 1 over 49, you get the gist of it. So in this particular case, with this particular problem, we're going to add the first 4, we're going to approximate the sum of the series with its first 4 terms. So in this case, the n value is going to be the first 4 terms. So what we're going to do is add the first 4 terms right there. Let's add those 4 terms together, and I'm going to grab a calculator very quickly and do this just real fast. So 1 minus 1/4 plus 1/9 minus 1/16, and let's fraction this thing. There we go, 115 over 144. So the sum of the first 4 terms is 115 over 144. So let's pause this and go back up to the top and talk about what this means. We have an infinite sum. So the infinite sum would be all this. The negative 1 over 36, we'll go here, plus 1 over 49, minus 1 over 64. You get it. You know, it keeps on going forever. So the entire sum is this, going forever and ever with alternating signs. Now, the partial sum, the first 4 terms in this case, would just be these 4, but then we get back to this variable, the sum of the remaining terms, starting with the n plus 1th term, that's a sub n plus 1, that's going to be, let's switch colors again, that's going to be this stuff. So from here and forever and ever and ever, this is going to be r sub 4, because we're actually starting after the 4th term. So let's continue to build an idea. This entire infinite sum is really this partial sum plus the remainder sum. That's this idea. All right, let's keep going. The sum, infinite sum, is a partial sum plus the remainder sum. Let's rearrange some variables. And then, because we have an alternating series, let's take the absolute value of it. So this is what we're dealing with. Absolute value of both sides works perfectly fine. So pause that idea, skip a space, that's why we do that. And let's talk about what this is. The remainder sum, this guy right here, is less than or equal to the next term. What does that mean? Okay, here's what that means. This series is doing something, I'm going to give you a visual for it. It's doing something quite amazing, and the amazingness is this. Here we go. First term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term, ninth term. We'll stop there. And 1, negative 1. Okay, here's my first term. I'm going to make my positives green and my negatives red. My first term was positive 1. So I'm going to add positive 1. Okay, this is 1. I'm just giving you a visual for it. My next term was negative 1/4. So my second term is 1/4 of this, but it's negative, so it's about right here. And there's that. And then the one after that is positive, and it's 1/9. So it's even smaller. And then the one after that is 1/16, and it's even smaller. And then the one after that is 1/25, so it's even smaller. And then the one after that is even smaller. And the one after that is even smaller, and the one after that is even smaller, and the one after that is even smaller. But it was positive, negative, positive, negative, positive, negative. Let's put this into context. Big positive, I mean, it's only one, but still, biggest positive minus 1/4 plus 1/9. Listen to the tone of my voice. 1 minus 1/4 plus 1/9 minus 1/16 plus 1/25. And it gets less and less significant as we go on. So you're really dealing with, let's make it less, less aesthetically pleasing. You're dealing with a situation like this. That positive minus that number, so plus that negative, that one, that one. And they get closer and closer and closer to zero. And because they're getting closer and closer to zero, the rest of these are, I would say, insignificant in some regard. Not completely insignificant. They are part of this infinite sum, but let's be really honest with ourselves now. Let's really drive this point home. Next term after this that I feel like writing, and you don't have to, but the next term after this is negative 1/36. I'm going to change this to a negative. And so if I'm going to figure out this sum, I have 1/25. That's the biggest thing going on. And then the next thing that happens is, of course, subtraction, but it has such a smaller magnitude. And the one after that has an even smaller magnitude and a smaller magnitude. And these smaller magnitudes with alternating signs really boil down to this. This sum, this infinite sum forever to infinity, is never, ever going to have a higher magnitude than that first term because of the wiggle room. Again, big, small, 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 with alternating signs means that we will never, watch it, we'll never have a sum in this regard larger than 1. Never. That's the biggest positive number, that's the highest magnitude you see, and so with that 1, it's just going to get smaller and smaller. That's it. That's what this line means. So the remainder is always going to be less than or equal to that next term. Okay, so taking this idea, let's recap a little bit. The infinite sum is the partial sum plus the remainder, and the remainder is less than or equal to the next term. Well, that means that the infinite sum minus the partial sum is equal to the remainder, which is less than the next term. Now it's getting wordy, but you can take out the middleman here, literally, and you have that. Okay, let's finish the problem down here at the bottom. We're going to approximate the sum of the series by its first 4 terms. So I want the sum of the series. I want the infinite sum. I need this infinite sum. I hope you remember, a few lessons ago I said there are times where we will not be able to find the infinite sum, but we can estimate it. This isn't estimating. This is how we estimate the sum of an alternating series with strikingly amazing accuracy. So I'm going to use this idea right here. And let's just keep writing. Oh, what color should I use? Purple sounds good to me. Briefly lost my purple pen. I was panicking. A panic purple pen. So I'm going to write this formula. I say this a lot, but the more you write, the more you'll remember. So if you need a refresher on a formula, I'd write it if I were you. So what we're really dealing with is S minus S sub n less than or equal to A sub n plus 1. So the infinite sum, which is what I don't know, and I'm not going to find it, but I'm going to get an estimate, minus my partial sum. We found it. 115 over 144. And we'll absolute value this thing. It's less than or equal to the next term, 1/25. So if I'm dealing with a situation where n equals 4, there's S sub 4, found it, and then A sub 4 plus 1, well, that's 1/25, so 1 over 25. And we will make sure it's positive for our purposes, because when you solve an absolute value inequality, you should, and this is not the only way to do it, but you could, since it's less than, put 1/25 here and put negative 1/25 1/25 there. Let's not make it 125th. Less than or equal to, less than or equal to, and s minus 115 over 144. This jump from here to here might be a stretch for some of you that have solved absolute value inequalities in a slightly different way. But basically the situation is this. This is bound to be less than that number in an absolute value way. So this number could have been positive or negative, so we sandwich it in between them. And so what we're going to do is, I'm going to show a little bit too much work here again. We're going to add 115 over 144, and we're going to add 115 over 144, and we're going to add 115 over 144, and we cancel, kind of like we're in Math 1 or Algebra 1, whatever you want to call it. S is in between these two things. The infinite sum is going to be something. Now, I don't know what that infinite sum is, and we have no way of ever fully knowing the infinite sum, but we can get a really good estimate. And if you're thinking ahead, if you want a really good estimate, you'll go further out. The further out you go, the better the estimate. Okay. Of course, this does need to be a convergent sum, a convergent series. I think that kind of goes without saying, but it's now said. So 1/25 plus 115 over 144, 144, and we get that. We're going to turn it to a fraction. Yes, okay, not the most practical fraction you've ever seen, but I like it, so we're going to do it. 3019 over 3600, and it is automatically reduced. And then we'll do the same thing over here. I'm going to insert a negative, and there's a glare. There we go. And there I am. Hey. And we will turn that into a fraction as well. So 2731 over 3600. There we go. Our sum is somewhere in between those two things. If you really care what those are as a decimal, and I am going to very quickly go one step further, let's decimalize these two things. And so I'm going to turn those into decimals. And this is 0.759. And this one is 0.839. So we have estimated our infinite sum to be that.